So, hello everyone, I am Aryan. Today I will be talking about how to become a type 2 civilization. So, introduction to Dyson structures. So, Dyson structures are theoretical megastructures that harness energy from stars. This concept was popularized by physicist Freeman Dyson in 1960. These structures are essential for understanding advanced civilization's energy needs. So these are things engulfing a star and they are getting its energy from it. So what is a Dyson sphere? A Dyson sphere is a hypothetical solid shell or swarm of satellites around a star. Its primary function is to capture a significant portion of the star's energy output. This could provide immense energy resources for advanced civilization. So Khalil, are you understanding it?
Yes.
Okay, so would you like to read this one? Uh, Khalil, can you read this slide?
Yes.
Okay.
Types of Dyson structures. There are various concepts of Dyson structures, including Dyson shells and Dyson swarms. Dyson swarms consist of numerous independent satellites orbiting a star. Each design has different engineering and resource requirements.
So there are various concepts of Dyson structures including Dyson shells and Dyson swarms. So Dyson swarms consist of numerous independent satellites orbiting a star. Each design has different engineering and resource requirements. So these are like solar panels. Okay, so I don't think so. Moving to our next topic. So Khalil, can you read this slide?
Advantages of Dyson structures. Dyson structures can harness vast amounts of energy far exceeding planetary limits. They could support life and technology on a scale
Unimaginable.
unimaginable with current resources. Such structures also represent a significant step toward becoming a Type 2 civilization.
So advantages of Dyson structures. So Dyson structures can harness vast amounts of energy far exceeding planetary limits. They could support life and technology on a scale unimaginable with current resources. Such structures also represent a significant step towards becoming a type 2 civilization. So these things can harness the amount and good amount of the star's output, and they are exceeding our planetary limits. uh, these things are built by type 2 civilizations which are way advanced than us. So Shreya, are you understanding everything?
Actually, I came so late, so I'm not understanding everything. But yeah, advantages of Dyson structures, if you'll explain, because before it you had explained in the last class. Am I right?
Yes. So uh, we were talking about Dyson structures. So there are two types of Dyson structures that we have discussed, which is a Dyson swarm and Dyson sphere. So Dyson sphere just engulfs the star, but if any accident happens, it can just uh, lead into the sun. But the second one was Dyson swarm, which is just a collection of solar collectors spreading the energy of the star in space. So yes, these are the things that we have discussed so far. So did you get it, Shreya? Uh,
Yes, Aryan.
okay. So can you read this slide, Shreya?
Yes, sure. Dyson Sphere. The idea behind a Dyson Sphere is to collect as much energy from a star as possible. On Earth, the total amount of energy we receive from the sun A value known as the total solar irradiance is 1361 watts per square, measured by NASA's Solar Radiation and Climate Experiment. Yet that is just a tiny proportion of the sun's total energy output radiated in all directions, which is 380 billion quadrillion, 3.86 into 1026 watts every second.
So the idea behind a Dyson sphere is to collect as much energy from a star as possible. On Earth, the total amount of energy we receive from the sun, a value known as the total solar irradiance, is 1361 watts per square, measured by NASA's Solar Radiation and Climate Experiments. Yet, that is just a tiny proportion of the sun's total energy output in all directions, which is 380 billion quadrillion, which is around 3.86 multiplied by 10 raised to the power of 26 watts per second. So, the
Why
thing,
can't we
what?
why can't we build a Dyson sphere?
So, to build a Dyson sphere, if we need too much material, and that material would be around 37 times all of the planet's mass combined, 37 times. So we have to destroy the solar system 37 times to get the material to build one. So it is a very heavy task. So did you get it, Khalil?
Yes.
Okay. So Shreya, do you have any question?
No, Aryan, please continue.
Okay. So introductions to black hole bombs. So black hole bombs are usually constructed by surrounding a black hole by a mirror. The fields propagating between the event horizon and the mirrors are prevented from escaping to infinity and reflected back to the black hole, thus undergoing repeated super radiant scattering, which leads to a linear instability. We introduce a new construction in which the field is outside the mirror and therefore is prevented from falling into the black hole, but is free to escape to infinity. So provided the mirror is inside the black hole, it turns out that this still causes some instabilities. So how it works is like we surround a black hole by mirrors and we shoot electromagnetic beams at it. So we need a rotating black hole which creates a ergosphere where if we travel faster than light, then we will be stable there. But if there is a process known as the Penrose process, where if we give a little mass to the black hole, we will get a push far greater than what we have given to the black hole. So this is known as the Penrose process, and this is how it works. So every time when it bounces off the glasses and the black hole, it gets stronger and stronger, and we can collect its energy by opening some windows. So yes, so how black hole bombs work? So black hole bombs utilize the interaction of particles with the black hole's event horizon through a process called superradiance. Energy can be amplified from the black hole. This could lead to potentially limitless energy extraction once properly harnessed. So this is talking about that. So theoretical implications of black hole bombs. Black hole bombs could enable civilizations to access energy far beyond stellar sources. They pose unique challenges including stability, safety of the energy extraction process. Understanding these concepts is essential for aspiring to become a type 2 civilization. So if we are not opening any windows, that thing can do explosion far greater than a supernova. So that is why its name is black hole bombs. So ladies and gentlemen, do you have any questions?
Who can destroy black hole?
uh, so a process known as Hawking radiation happens. So what happens that there are there are there are some things happening at the event horizon, which are uh, what we can call particles popping in and out of existence. So if that thing happens near the event horizon of the black hole, one can escape, but one will fall into the black hole. Thus, and some energy would be lost. Some energy and mass would be lost from the black hole, but it is very slow. So, an average black hole would have around 10 raised to the power of 100 years, or a Google years. So yes, this is how a black hole is destroyed. So Khalil, is do you have any
What
further
is
questions? What?
what is a black hole explosion?
Okay, so what happens that if we like the electromagnetic beams that we have shooten to the black hole, they get stronger and stronger each time they collide. But if we do not open any windows, what will happen that it will get stronger and stronger, and then it will just blast the mirror and thus creating a explosion. So did you get it, Khalil?
Yes.
Okay, so any further questions? So Shreya, do you have any questions? Uh, Hello Shreya.
No.
So can you read this slide?
Yeah, sure.
Okay.
A type second civilization can harness all the energy from its star, estimated at about 10 square watts. Sorry,
10, 10 raised to the power of 26 watts.
in raised to the power 26 watts. Achieving this level of energy consumption necessitates advanced technology and infrastructure. This is a crucial step toward progressing beyond our current technological limitations.
So yes, energy requirements for a type 2 civilization. A type 2 civilization can harness all the energy from its star, estimated at about 10 raised to the power of 26 watts. Achieving this level of energy consumption necessitates advanced technologies and infrastructure. This is a crucial step towards progressing beyond our current technological limitations. So if we want to become a type 2 civilization, we would need an energy consumption of around 10 raised to the power of 26 watts every second. So like till now we have discovered two things to become a type 2 civilization, but we cannot do we cannot do any of them because we do not have the resources, etc. But there are few things that we can do to advance, and we will discuss further. So steps towards becoming a type 2 civilization. The transition involves mastering energy collection, storage and utilization methods, developing advanced technologies such as Dyson spheres and black hole bombs is essential. So collaborations on a global and interstellar scale could accelerate this process. So current research on Dyson structures, scientists are exploring materials and technologies that could facilitate Dyson structures constructions. Research involves solar power stations and energy transmission systems. So advancing in artificial intelligence can optimize the design and development of these structures. So, do you have any questions, Khalil and Shreya?
No.
No, Aryan.
Okay, so Shreya, can you read this slide?
Yeah, sure.
Okay.
The role of nanotechnology. Um, Nanotechnology could revolutionize the construction of Dyson swarms and megastructures and other megastructures. It allows for the manipulation of materials at the atomic level for maximum efficiency. This technology could significantly reduce cost and increase
Feasibility. So the role of nanotechnology could revolutionize the construction of Dyson spheres and other megastructures. It allows for the manipulation of materials at the atomic level for maximum efficiency. So this technology could significantly reduce costs and increase feasibility. So I have some questions for uh, Khalil and Shreya. So, can you explain to me what is a Dyson sphere? Shreya? She left. So, Khalil, can you explain to me what is a Dyson sphere? Khalil, are you here?
Yes.
Can you explain to me what is a Dyson sphere?
A Dyson sphere is a sphere about the size of a planetary orbit that's made of solar energy collectors. It
Okay.
would harvest the star's energy and emit excess heat as infrared radiation.
Okay. So, can you explain to me what is a black hole bomb then? Uh,
Black hole bomb is a physical effect that occurs when a bosonic field interacts with a rotating black hole,
yes.
resulting in an
Exp-
amplification of the field through supradent scattering.
okay. So, Khalil, would you like to read this line?
Yes. Energy energy storage technologies. If efficient energy storage systems are critical for managing the energy collected by Dyson structures. Advanced batteries and other storage solutions will enable a consistent energy supply. Innovations in energy storage will help facilitate
Smooth
a smooth, a smooth
trans- transition to.
transition to Type 2 civilization status.
So, efficient energy storage systems are critical for managing the energy collected by Dyson structures. Advanced batteries and other storage solutions will enable consistent energy supply. Innovations in energy storage will help facilitate a smooth transition to Type 2 civilization status. So, challenges in building Dyson structures. So, engineering challenges include the required materials, constructions, methods, and stability. The vastness of space and potential collisions might be considered in the design. And addressing these challenges is imperative for making Dyson structures a reality. So, the picture given is of a Dyson sphere, but if we decided to build one, we will not build a Dyson structure, Dyson sphere. We will build a Dyson swarm because it is more viable to use. Because of what if a asteroid collided with the sun, so it will just ruin all of the Dyson sphere, right? So, ladies and gentlemen, do you have any questions? Khalil, do you have any question?
No.
Okay. So future of Dyson structures and black hole bombs. So the integration of these technologies will shape the future of space exploration and energy use. Ongoing research and development are critical for pushing the boundaries of our capabilities. The vision of a Type 2 civilization remains an exciting frontier for humanity. So these are still right now impossible to build because of their and because we need too much energy and resources. I think so. Someone named as Srijana joined. So can you introduce yourself, Srijana? Hey. Okay. I'm Srijana. So where are you from? So Nepal. So do you have any interest for science? Do you know what is going on here? No. So okay, I will explain. So we were talking about Dyson structures and black hole bombs. So black hole bombs are things uh, if uh, if we surround a black hole with mirrors and shoot electromagnetic beams at it, a process known as Penrose process happens, and the waves would get stronger and stronger, and if we need any energy we can open some windows to get the energy from it. And Dyson structures, if uh, if we build a Dyson sphere, it will collect energy and give us that. It is a shell encompassing the whole sun. But there is another type called Dyson swarm, which is a bunch of solar collectors surrounding the sun and is more efficient. So did you get it, Srijna? Okay, I think so. Okay, so asteroid mining. So this is the thing that we can do right now if we want to do it and spend enough. So Khalil, would you like to read this? Khalil.
Asteroid mining. Asteroids may be a much better place to get the supplies. Early evidence suggests that there are trillions of dollars worth of minerals and metals buried in asteroids that come close to the Earth. Asteroids are so close that many scientists think that an asteroid mining mission is easily feasible. Several international organizations are developing plans for going up to get these natural space resources.
Okay, so asteroid mining. So asteroids may be a much better place to get the supplies. Early evidence suggests that there are trillions of dollars worth of minerals and metals buried inside asteroids that come close to the Earth. Asteroids are so close that many scientists think that it is an easy mission and very feasible. Several international organizations are developing plans for going up to get those natural space resources. So yes, this is the thing that we can still do right now, and we have the capability to do this. And if we mine a very rich asteroid like one called Psyche, it is about some quadrillions of dollars of worth, and if we mine that hole we will get sources for millions of years. So it is being said that a single asteroid might be worth trillions of dollars in precious rare materials. Just a single 30-meter asteroid like the recently discovered 2012 DA14 is worth $20 trillion. Scientists think the M metallic types asteroid 16 Psyche is compared mostly of metallic iron nickel similar to the Earth's core. 16 Psyche has a mass of about 2.7 multiplied by 10 raised to the power of 19 tons and is 90% iron. If we extract around 2.5 multiplied by 10 raised to the power of 6 tons of iron ore per year. At our current consumption rate, Psyche can cover our needs for billions of years. Even if we increase our consumptions, it would still supply us for millions of years. So this thing is worth around a quadrillions of dollars. So Khalil, do you have any questions?
No.
आर्यन रमेश भी ज्वाइन कर रहे हैं, प्रोफेसर है।
So
नमस्ते कविता।
So Ravi sir, I think so Ramesh sir has joined. So namaste sir for joining, and I hope that you will like the session. So my name is Aryan and I am 11 years old. So we were discussing about how to become a type 2 civilizations. So we were currently on asteroid mining. So I hope sir you will enjoy the session. So so now we are in the Matryoshka brain. So it is and thing that can be used if we become a type 2 civilization. So A brain, it is an asteroid brain based upon a computational substract comparable in mass and size to an asteroid smaller than a moon brain. So these are just types of Matryoshka brains, like MV multiverse brains, UV universe brains. So these are just types of Matryoshka brains. So Matryoshka brains are way beyond iota scale computing. So 1.12 multiplied by 10 raised to the power of 36 flops is its estimated computational powers, assuming 1.87 multiplied by 10 raised to the power of 26 watts, possibly solar. So these flops are just thinking capacity, you can say. A normal human being has a capacity of around 10 raised to the power of 13 flops. So these are way stronger, and this is for type 1 prototypes, a nanomechanical implementation of the computerum which would allow us to push close to the limit of energy efficiency can generate about 10 raised to the power of 47 flops. This is for type 2 civilizations. So alternatively, 4 multiplied by 10 raised to the power of 48 flops is the estimated computational power, with the power source is the sun, with the ideal efficiency of Carnot engines. So this is for type 2 civilizations. So we will make some further presentations on these after some times. So 5 multiplied by 10 raised to the power of 58 flops is the estimated power of a galaxy used by Matryoshka brains. This is for type 3. A UV brain is able of 10 raised to the power of 90 operations per second. So if all the matter in the universe was turned into a black hole, it would have a lifetime of 2 multiplied by 8 2.8 multiplied by 10 raised to the power of 139 seconds. So during that lifetime, such a B brain would perform around 2.8 multiplied by 10 raised to the power of 229 operations. So if there are 510 raised to the power 500 kinds of universes in multiverse, then a quantum computer in MV brain would manage around 10 raised to the power 600 operations per second. So this is the Matryoshka brain, which is way beyond our capabilities right now. So these can be a reality after we become a type 1 civilization. So these flops are nothing but operations per second. So our is around 10 raised to the power of 13 flops. So do you have any questions, Khalil? Khalil?
No.
Okay.
आर्यन
So
फिर से एक बार बताओ सबको, फिर से काफी सारे पिंकेज
okay, so I think so. Pinkesh has joined. So can you introduce yourself, Pinkesh?
Actually, I am Shreya here.
Okay.
I
So
left the class because of network problem, and now I joined. So sorry. The time when you asked questions to me, and I left because of network problem.
okay. So do you know about what is a Dyson sphere?
Yeah, it is a mega structure. Am I right?
Yes.
Surrounded by stars.
So so we discussed about asteroid mining. I will open that. Yes, we discussed asteroid mining. So so these things suggest that they can be worth trillions of dollars, and one asteroid named 16 Psyche has too much mass, and if we mine that, so we will get to so we will get materials for billions of years. So yes, uh, Pinkesh, so do you have any questions about asteroid mining? Shreya,
No,
do you?
Aryan.
Okay. So,
No, I
so
think I'm not understand, but um, uh, I'll see it afterwards.
okay, so
If I have any doubt, I'll call you and ask anything.
okay,
Just send me the PDF.
okay. So and then we were on the Matryoshka brain. So these are things composing of stars and this. So if we get a star and use its all energy to make a computer, then it would be called a Matryoshka brain. So these are way beyond our understanding right now, and these are far better than any of our computers that are present right now. So as you can see in the slide, there are flops given. So flops are just thinking capabilities. An average human is about 10 raised to the power of 13 flops. So these are way stronger than any of our human and computers. So there are many types of Matryoshka brains. Like some of them are asteroid types, stars, type 2 civilizations, and some of them are galaxies. So Shreya, do you have any questions about Matryoshka brains? Shreya,
Yes.
do you have any questions about Matryoshka brain?
No, Aryan, please continue.
Okay. So Khalil, do you have any questions?
No.
Okay. Did you get it? Matryoshka brains and asteroid mining.
Yes.
So can you explain to me what is a Matryoshka brain? Khalil? Okay, I don't think so. So conclusion. So to become a type 2 civilization, we need to make Dyson spheres or a black hole bomb and a Matryoshka brain. So we need a energy output of the sun. People think we can reach this level after around 5,800 years if we survived. So yes.
Matryoshka brain is a hypothetical megastructure that uses a star's energy to power a computer system with immense computational capacity.
Okay. So can you explain to me what is a flop?
Can you repeat?
Can you tell me what is a flop? Okay. No. Okay, so a flop is a computational power. So an average human is about 10 raised to the power of 13 flops, or you can say operations per second. So, Sadia Mehra has also joined. So Ryan, do you know what is going on here?
No, I just joined.
Okay. So so hello everyone. My name is Aryan. So we were discussing about how to become a type 2 civilization. So I will summarize the presentation here. We were talking about Dyson structures. So Dyson sphere is an structure that is engulfing the sun, and we will get that energy, but it is not too much viable because any collisions with the star would make it non-existent. And it has another type, a Dyson swarm. It is a bunch of solar collectors that are spreading the energy of the star through space, and black hole bombs, so engulfing an black hole with mirrors and shooting electromagnetic beams at it. So with every hit it takes, it becomes stronger and stronger, and if you want any energy, we can open some windows and get that energy. And these are all things that we can do after we have become an type 1 civilization, and things that we can do right now is asteroid mining. Asteroid mining, so an asteroid can just power us for some millions of years, like 16 Psyche, which is estimated to be worth of quadrillions of dollars. And last thing, Matryoshka brains. So these are things that use the power of galaxies, stars and planets to power computers, and those computers have too much computational power. So yes, this is all we have discussed till now. So ladies and gentlemen, do you have any questions? So Sadia Mehra, you have raised your hand.
What type of civilization are we living in now?
So we are right now 0.75, not even type 1. People say that we will reach type 1 civilization in few hundreds of years. So any further questions? Okay. So Nikhil Bhaiya, do you have any questions for me?
No, I am.
So sir, did you like the presentation?
Yeah, actually, I have joined little bit late today, but
Yeah.
as far the concept of your presentation is good.
Yes. So so do you want to add something to the presentation?
No, as far I don't have anything to add. I was also just checking the presentation.
Okay. So Khalil, uh,
Yes.
so do you know how much energy requirements are needed for a type 2 civilization? Uh, do you know that, Khalil?
Yes.
So can you tell me how much energy requirements are to become a type 2 civilization? Okay, I don't think so. So should I tell the answer, Khalil?
10 to the power of 26 watts.
Okay. So any further questions from anyone? Ryan?
No.
Ryan, do you get everything? Like, did you understand? Uh,
Yes.
okay. So can you explain to me what is a Dyson sphere? Ryan?
Yes.
Can you explain to me what is a Dyson sphere? Okay. So should I answer that?
Yes, please.
So Dyson sphere is a bunch of solar collectors that are collecting the energy output of the star and spreading it through the space. So yes, it is just engulfing the star and giving its energy to us. So I think so we are done with the presentation. So if you have any further questions, you can tell me. Some Ashish Ashit Chakrabarti, I think so someone new has joined. So can you introduce yourself? Ashit Chakrabarti.
Yes,
So uh, where are you from?
I am from Kolkata.
Okay. So do you have any interest for science?
Yes, but I have joined now.
Okay. So I think so some scientists also join from Kolkata. Bhava Atomic Center. I think so. He worked there. Uh,
Okay.
so, uh, did you know what was going on?
I don't know.
Okay. So, okay, I will explain to you. So, we were discussing about types of mega structures like a Dyson sphere. So, Dyson sphere is an mega structure that is engulfing the star and getting its energy. Uh, Second was a black hole bomb. So, if we surround a black hole with mirrors and shoot electromagnetic beams at it, they will get stronger and stronger by each collision, and we can get some energy by opening some windows. And third was asteroid mining. We can get resources from mining asteroids like 16 Psyche. And last thing, Matryoshka brain. So we can make a Matryoshka brain by using the energy of stars, galaxies, and the whole universe to power a computer. So they will have too much computational powers beyond our imagination right now. So yes, this was the whole thing that we had discussed. So
Okay. Thank you.
do you have any questions about it?
No.
Okay. So so uh, Shreya, is Shreya
Yes,
here?
Aryan.
Yes. So uh, can you explain to me uh, what is the Matryoshka brain?
Actually, I was not present in that.
Okay. So I think so. I would ask some general questions to you.
Yeah.
Okay. So I hope that you can answer that. So do you know uh, how much is a mole?
What?
How much is a mole? Do you know?
Mole.
Yes. It is used for measurements. Okay. I don't think so. So Khalil, can you answer that? How much is a mole? Okay. Khalil.
Yes.
So can you answer how much is the mole?
6.02214076 into 10 to the power of 23.
Yes. So how much is a ream? That
Can
you
you
know?
repeat?
How much is a ream? Do you know that?
16 pixels.
No. Ryan, can you answer that? How much is a ream?
16 pixels.
No. Ryan, can you answer that? How much is a ream? Okay, I don't think so. He knows. So I'm going to answer that. So 500 was the answer. So Khalil, I have a question for you. Khalil,
Yes.
so do you know who is the chairman of ISRO? It's an easy question. Uh, do you know that, Khalil?
Yes.
Okay. What's his name?
Dr. S. Somnath.
Yes. So, in which class are you, Khalil?
In 8th.
Okay. So do you have any questions for me then? Okay, I don't think so.
No.
So, so anybody else?
Hello.
Yes. Yes.
I want to tell you something about time machine.
Okay.
Are you interested?
Okay. So, what do you want to say about that?
It's my innovative thinking also. That is, if we, if I suppose we know that time machine is a multiplication product of length into breadth into height into time.
So, okay. I don't think so. I'm getting it. Yes.
If we suppose present as x-axis, past as y-axis, and
Yes.
future as z-axis,
Okay.
and if it is rotated automatically, we can invent the time machine. It's
Okay.
also my innovative thinking. I don't know if it is right or wrong.
Okay. So, do you? So, I have also something to say about time travel. So, if I
Okay.
suppose if I traveled near a black hole and like not too near that event horizon, and if I stay for some long time, the time will be slowed for me, but in my clock it would be going uh, normally, but the people which are uh, seeing me will say that he is not what you can call moving, or he is very slow. So yes.
Yes, yes, yes.
So that is also a time travel where time will travel slow for you.
Yes.
So
It
yeah.
it was it was also invented by Sir Albert Einstein,
Yes.
I
So
think,
in
with
or
the equation of E is equal to mc square.
yes, and that was gravitational time travel. So if I travel at very high speeds, time will also slow for me also.
Yes.
Okay. So do you have any other interests in science?
I have interest also, but I don't know anymore.
Okay. So in which class are you, Asif?
I am studying in class 12.
Okay.
Much idea about
So you have much idea. Eh, So someone has raised their hand. Sadia Mehra.
Yes, which is the nearest black hole?
Okay, so I think so. It is around 1,500 light years away from us. I'm forgetting the name. I can't remember the name, but it is around 1,500 light years away from us. It is around 5 to 10 times more massive than the sun. So yeah. Uh,
Which is the biggest black hole?
10618, it is around 66 billion solar masses, which is around 66 billion times more massive than our sun. So any further questions, Ryan?
No, that's it. That's it, I doubt.
So can I ask you something of general knowledge?
Yes.
So how many chambers does a crocodile heart have? Do you know that? How many chambers does a crocodile heart has?
14.
No. No. Okay, so Khalil, can you answer that?
It is 4.
Yes, you got it. So, uh,
Nikhil भैया ने कहा और वहाँ से अस्सी चक चक
so Nikhil भैया,
Yes, Aryan.
So, do you have anything to say about the presentation, or do you want to add something now?
No, Aryan, as far I don't have anything to add.
So, okay. So,
Presentation was good.
can you give me any suggestions? What should be the next topic?
Next topic, we will have something interesting. Like in this topic, you have covered type 2, right? Regarding the Dyson Sphere and all.
Yes.
So next time you can try with type 3. Type 1 is completed for you in previous week.
Okay. So,
I mean, did you? I mean, last presentation, last week I didn't attend it
okay.
presentation. Last week is it type 1 civilization you have covered?
No, I have covered about a strange star.
Okay.
So, yes. So,
Not
do you have anything else to say, Nikhil sir?
no, no. As far I don't have anything, I will
Okay.
just go through your YouTube video if possible.
Okay.
Yeah, I will let you know personally. Okay.
Okay. So, see, Chakrabarti, do you have any suggestions on what should be the next topic? Asit? Okay, I don't think so. He's there. So, Shreya,
Yes.
so do you have any suggestions on what should be the next topic?
I think you may go through stars.
No, I don't think so. I think so. We have discussed about them already.
Okay. So any star that is um much bigger than the sun.
Okay. So, okay, I will think about that. So,
Or about any we have assist we have our planets in a Milky Way. So find some other ways. Can I?
okay, so Khalil, do you have any other suggestions on what should be the next topic?
Mapping the celestial bodies.
Okay. So yes, I will think about that. Uh, I also have a little bit idea of mapping the stars in the sky. So someone has raised their hand. So yeah,
message on.
cause someone was trying to say something.
Yeah, yeah, yeah. Excuse
Yes.
me. Actually, did you cover these topics? Quasars and supermassive black hole.
Yes. I yes, I
These two
think so.
topics
I
you have covered.
covered it in our previous presentations. I think so.
Okay, quasars.
Okay, I will think about that quizzes.
Yeah, quasars and supermassive black hole. Those are the interesting topics actually.
Okay.
We recently also got some pictures of this supermassive black hole in Milky Way.
Yes.
Those things you can take the presentation. I was just, I mean, if you didn't cover these topics in earlier presentations, you can do that.
Yeah. So, uh, Rayan, do you have any suggestions on what should be the next topic? Rayan,
Yes.
do you have any suggestions on what should be the next topic?
You can talk about all how many planets are there in the whole universe.
Okay, okay, I will also include that one.
Do you know about cosmology?
Oh, what, Khalil?
Do you know about cosmology?
Yes, it is about it is the study about the origin and the fate of the universe, right?
Yes.
Okay. So, do you want to make a presentation about that?
Yes.
Okay, I will try. So, how is the presentation, Khalil?
It was good.
So, I am thinking about to. I am thinking
Hello.
that. Yes, Asit.
Um, I want to tell you a story
Okay.
about
What?
Sir Albert Einstein.
Yes.
It's a short story also.
Okay.
Once I want to share it. I read it past. I read it at past in a science magazine.
Okay.
Once a reporter asked Einstein, "Where is your science lab and where are the apparatus of invention?" Hearing the question, Einstein showed his own head and said, "This is my science lab," and also said to show his pen from book pocket, "This is my apparatus of invention."
Okay.
Hearing that the reporter became so amazed that he did not speak anything.
Oh. So, Asit.
Do you know the incident?
No. No, I don't think so. I had read this anywhere. So, Asit, do you have any suggestions on what should be the next topic?
Rocket science.
Okay, so rocket science and anything else?
About space traveling.
So, okay, I will try to make a presentation about that. So, Asir, do you know about the fundamental laws of the universe? Uh, like, so Khalil, do you know about the fundamental forces of the universe? Khalil,
Yes.
do you know about the fundamental forces of the universe? Uh, do you have any idea about that? Fundamental forces of the universe? Yeah, I don't think so.
It is the interaction in nature that appear not to be reducible to more basic interactions.
Okay, so can you name a few of them?
Gravitational force,
Yes.
electromagnetic force,
Yes.
strong nuclear force, weak nuclear
Electro.
force.
Yes. So so, uh, but Einstein believed that gravity was just an illusion because he thinks that the universe is a flat surface where the gravity is caused by the curvature of things. So yeah, but he believed that it's just an illusion that is caused. So okay, I think so we should end the meeting till now.
इनके बारे में पूछो आर्यन आर्यन
Yes.
इनके बारे में पूछो रमेश सर के बारे में निखिल सर
So Ramesh, so Nikhil sir, I have a question for you. Do you know Ramesh sir? Uh, uh, Nikhil sir? Nikhil sir, are you here?
Yes, yes, Aryan.
So do you know about Ramesh sir? He joined the class. Uh, do you know
No,
about him? Uh,
no, I don't know about him.
okay.
I mean, previously someone else contact to me.
फिर सर पूरा
I mean, for our first anniversary, we have celebrated, right? So at that time, as a speaker, I asked. him, I guess, Ramesh sir, but I didn't get any response.
Oh, his full name was Professor N.P. Ramesh. So
Yeah,
yeah,
yeah. I mean, he used to publish some blogs and all in Blue Space Book and all the videos.
okay.
You
So
can see his blogs.
okay, so what he used to do?
Maybe he's a professor, I guess.
Okay. So
I don't know much information about it. I will check with him. Okay.
okay. So eh, so uh, okay, I think so. That's it.
Okay. Sorry, I didn't contacted him earlier. It was, I think, different person I have contacted, not MP Ramesh.
Okay. So should we end the meeting now?
Yeah, yeah. If
It's
you don't have anything, you can end it.
okay. So yeah, I'm going to leave right now.